Hello friends, welcome to our channel Castor Classes, and in this particular video I am going to discuss how you can efficiently turn off the rightmost set bit of a binary number. Okay, suppose I am taking one integer number c equal to 10. If I do binary representation of c, I will be getting 1010. Now see, remember one property I have discussed. Suppose I am writing d equal to 9. So what is binary representation of 9? Can you tell from the binary representation of 10? Yes, as 9 is nothing but 10 minus 1. So binary representation of 9 will be having the from the binary representation of 10 we can extract this. How? See, rightmost set bit in binary representation of 10 is this one. So left to that all the bits will be same. I am pasting that, so 10 came, and from the rightmost set bit in the right hand side whatever bit is there, that will be reversed. So here it is 10, so here this will be 01. So this is binary representation of 9, as we know. If you run, you will be getting that only. Now what you can do, remember this as property. Whenever you perform n and n minus 1, that is binary representation of n and binary representation of n minus 1, if you perform bitwise AND operation, then always the rightmost bit will be set. Like here, if you check 1010 and 1001, see what will happen eventually. See, 11 binary 11 AND operation, bitwise AND will be 1, 00 bitwise AND operation is 0, 10 bitwise AND operation is 0, and 01 also bitwise AND operation is 0. Okay, so see, just what we have done, we have performed bitwise AND between n and n minus 1, and like that we had turned off the rightmost set bit, because you see here rightmost set bit is 1 here appearing, right, which is now 0. Okay, very simple logic. Like let me show you one more example. Suppose d equal to 45. Okay, now what is binary representation of d? That is this one. Okay, now what I will be doing, binary representation of d and 45 minus 1, that is 44. If I run, see what we will be getting, 101100. Okay, so compare these two. See, only the rightmost set bit is turned off. Okay, here it was 1, here it becomes 0. Last example, suppose I am showing let us take one number, suppose b equal to 100. Okay, so binary representation of 100 is what? See, 1100100. Okay, so if we want to turn off the rightmost set bit, that is this, we have to turn off. So what we should get, output 1100000. Okay, see what I am doing, I am just calculating binary representation of b with b minus 1. Okay, b and b minus 1. Okay, if I run, see, I'll be getting 110000. Okay, that is rightmost bit is basically which is set bit, that is basically turned off. Okay, so this is very important property of binary number, again you can say. So remember this, because in interview many times this question appears, that how you can turn off the rightmost set bit efficiently. There is other way that you can apply one for loop. You can traverse in the string representation of this particular binary number, and you can, whenever you are getting rightmost set bit, okay, that you can make to 0. Like that string traversal will obviously take what time complexity? O of n at least. Okay, but here we are computing in O of 1 time complexity, that which is very much optimized. Okay, so keep this property in mind. This might help you in competitive programming. So this is all for this video. If you find this video helpful, please like, share and comment, and subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.